In today's video, we are going to mess around with some Mac SE30s, the fastest original black and white compact Macs. I have already featured two of these in a previous video. The Mac to the right here had a massive battery bomb. That board is an absolute horror show, so this machine is going to be a donor for a brand new motherboard. The Mac in the middle here was slightly luckier. The battery hadn't exploded, but the caps had leaked pretty badly. So this machine is just partially working, and the motherboard needs a repair. The third Mac here is completely unrestored, so I think that's where we'll start today. This Mac also came with a hard drive that the previous owner had smashed, so we're gonna try to repair that hard drive today too, as a fun side project. I have already removed the motherboard from the third machine here. I have removed the battery and all the surface mount caps, and washed the board. And this board too had one of those black mystery batteries that don't seem to explode. There is some damage from the caps though, but not as bad as with this machine here. Fingers crossed, let's hope this board is good. I already have piles of stuff to repair, so it would be nice if this board just worked. It's been a while since I took that board out, so I don't remember what the condition is inside this machine. But the case is decent, it has some scuffs. But it looks like it would clean up quite nicely. So let's pull that Mac out and find out. Oh, that's not bad. Not bad at all. This is a really clean machine. There is a tiny bit of dust in here, but hardly any soot. So that tells me that tube is in excellent condition. I also noticed that it has a much older looking hard drive. So either someone has replaced it or this is an earlier machine. We'll check all the dates in a minute. Actually, I think we already have a date here. 9005. So that's quite possibly week 5 of 1990. And these machines came out in 1989. I think I did a pretty thorough disassembly in my previous SE30 video. So I'm going to skip through this part quite quickly. But I already noticed something here. One of the screws on the hard drive is missing. And one other screw is loose. The LED here is also disconnected, and actually all 4 screws are loose. I guess it could still be the original drive. Okay, let's take it out and have a look underneath. No, this is probably the original drive, because dates are late 1989. I thought these kind of drives were older. I guess I was wrong. Well, the rest of the machine was clean, but not the super drive. It's jam-packed with dust. So place your bets. Are we going to find a cheese cog in this drive? Okay, and the analog board looks great. I don't see anything leaking or bulging. So this board doesn't actually need any cleaning. That's a rare sight. But I'll just leave it like this. And same thing inside the power supply. Nothing is bulging or leaking. And there's absolutely nothing to clean in here. This power supply looks brand new. Okay, I'll do all the cleaning off camera, so we can move on to something more interesting. And see if we can fix this board. So dates are very early in 1990. So that was indeed the dates we saw on that power supply. Let's move in real close on the board and check the condition. Well, as I mentioned, the battery hadn't exploded. So there is no damage in this area at all. And then we have the empty pads for the removed C13 here. This looks much better than the previous board. There's a tiny bit of corrosion on some of the vias here, but not much. I didn't bother ordering these axial caps for the previous projects, because these caps rarely go bad, at least in my experience. But since they looked suspicious, I ordered some of these after I made that previous video, so we can replace these guys too. Next we have the empty pads for these 3 guys here. Close to the power connector. Pads look fine, and same here. I think there's a tiny bit of corrosion on the vias, but not much. However, the cap juice went this way here, so basically the pins on all 4 sides on these 2 chips here. They are corroded and need some cleaning, and same thing with these 2 chips here. They have green corrosion on all 4 sides. Now I have already washed this board once, so this was probably a lot worse before the wash. But those pins definitely need some cleaning. And moving over to C7 here. Pads look really good, and just some tiny bit of corrosion on the vias here. Then the cap juice went this way, and messed up the pins of these chips. So we're gonna have to clean these too. And same thing with this axial Nichicon here. I think I have a replacement for it. And then we can move over to these 4 sets of pads here. And same thing here. Pads look good. Just a tiny amount of corrosion on the vias. But all the nearby chips have some corrosion on the pins. All the way down to these 2 guys here actually. So we need to do some cleaning before we install those new caps. But at least the pads and the vias look good. So keep your fingers crossed. Board looks good on this side. So the cap juice doesn't seem to have found its way to this side of the board. And I found the axial caps in my stash, so we can go ahead and remove them. Well, that didn't go too well. Okay, let's try again. With some fresh leaded solder added to the pads. Yep, that did the trick. Okay, let's start cleaning stuff. I'll start with this row of chips here. So only 3 of these have corroded legs. So this board is definitely in better condition than the previous board. I'll add some flux and a splash of solder on the tip. And then I'm just going to drag solder all 3 chips. And I will probably have to do this process several times to get all the corrosion off the legs. And if we're lucky, that cap juice never found its way inside the chip, which it actually rarely does. But sometimes it can. Yeah, it's already starting to look much better. Well, this is going to be a bit repetitive, so I guess I'll do this row of chips here and skip ahead. Okay, I think this row is done now. I clean as I go, because I hate having a huge mess to clean up at the end of the project. With most of the flux gone, I'll use some IPA and clean some more so we can do a proper inspection and make sure all those solder joints look good. Okay, and here's the results. That looks pretty good to me. All the corrosion is gone from those legs by the magic of good flux. And next up we have this VLSI chip here. Not as bad as some of the others, but definitely corroded pins. So we need to clean it. I'll add some flux. And the largest tip I have to add a really big blob of solder. I checked and all 4 sides were corroded. So I'm going to have to clean all the pins on this chip. So I'm not pushing or scraping off the corrosion. I'll let the heat and the flux do the job. Drag soldering like this of course leaves some bridges. So I'm just going to push all the excess solder to one side. And that tends to remove the bridges quickly and easily. Okay, this chip is done. I'll scoop up the flux right away while it's still warm and easy to remove from the board. If the bridges are a bit stubborn, adding some more flux usually helps. Okay, and here's the result. All 4 sides of that chip have nice and shiny pins. And the reason why I cleaned them is because if the corrosion is left on those pins, it will most likely continue to corrode and eventually kill that chip. Okay, next up we have these 2 guys here. Now those are some pretty crusty legs, so let's clean them up. So let's add some flux. And again, I'll just let the flux and the heat do the job of removing all that corrosion. So first the pins barely take any solder, but after a few seconds the flux does its magic and all the pins eventually get tinned. Okay, and here's the result. All pins and pads nice and shiny again. Since I was in this corner here, I also fixed this guy here and these 2 larger chips here. And the Zilog chip next to these guys, strangely enough, doesn't have corroded legs. But the chip next to it definitely does. Yeah, some pretty crusty pins here. That chip definitely needs some cleaning. And it's sitting next to these caps here. This is actually the last chip on this board with corroded pins. I'm not going to repeat myself, so I'll do this guy off camera completely. Okay, and here's what that last chip looks like after some cleaning. A hell of a lot better than before. Okay, as far as I can tell, all the chip legs are free from corrosion, so we can install fresh caps on this board. Place a blob of solder on the pad, reflow the solder and add the cap. And then I'll solder the other side. So C6 is 1 microfarad 50 volt cap, and the remaining SMD caps are all 47 micro 16 volt caps. There are quite a few of them on this board actually. If you ever need a cap list for a vintage Mac, check out recapmac.com. Well, I'm not going to repeat myself 10 times here, so I'll skip ahead. Okay, all SMD caps installed. So now we can install the 2 axial caps. So we've got a 470 microfarad 16 volt cap here. And on the other side, we've got a 220 micro 16 volt cap. Okay, so all the caps are on the board. And normally I would wash the board at this point to get rid of all the flux. But unfortunately I don't have one extra day to wait for the board to dry before we can test it. So instead I'm going to use IPA in a spray can and blow the flux out from underneath all the chips we have fixed. That should make it clean enough for a test. And then I can wash this board later. Okay, moment of truth. Let's see if this board is a survivor. I have connected the motherboard with an ATX extension cable to the SE30 with the broken motherboard. And connected the speaker. Here goes. Okay, we've got a mouse cursor. I don't have a diskette drive or hard drive connected yet, but that is looking good. So we've got a question mark here. Okay, untested diskette drive connected, and that's the drive from this machine with the broken motherboard. And a random diskette in the drive. Here goes. Okay, so still a white screen and a mouse cursor. Let's see if it will try to boot from that diskette. Okay, and I think it's working. At least it's reading and loading something. Yes! Welcome to Macintosh! Haha! So, this board is a survivor. Awesome. Finally a working SE30 on the 3rd attempt. I still plan to fix the other 2 machines. But the first goal here was to get one of them up and running. And I think that goal is now achieved. Okay, disk tools loaded successfully. So I'm gonna call this a success. And now let's have some fun with this messed up hard drive. Let's move back to the bench and have a look at it. So we found this drive here in one of the other 2 machines. And by the looks of it, I think the previous owner didn't want anyone else to have access to his data. But unfortunately he seems to have used a blunt tool to do so. The first obvious sign to the destruction is this connector here. It has been completely mangled. So we're not going to connect anything to this connector. And then we have this poor little chip here. One of the pins has been ripped off completely. And several of the other pins have been mangled. This crystal here has been knocked off one of its pads. And then we have a completely missing crystal here. Over on this side we have 2 legs poking out of the PCB. And that is what's left of C201. But luckily inside the Mac we found what's left of that cap. It's a 33 micro 25 volt cap. We also found a crystal and a big gaping hole on its side. This, by the way, is a Quantum Pro Drive 105S. Now, blunt tool is not the way to securely erase the data on a hard drive. So I thought it would be a fun side project to see if we can help him out and securely erase the data on this hard drive. Now, to do so, we obviously have to repair the drive first. I also noticed that there are quite a few scratches on the board, so we're gonna have to check those traces for continuity. Now let's get that board off the drive. See if this can be fixed. Okay, I think those screws freed up the PCB. And under here we have some sort of shield made out of copper. And if you have seen my Mac 128 mod video, you know why that shield is important. Let's start with this cap up here. This should be an easy fix. Well, I found a cap in my stash, but it's way too big for this board. So I'm gonna have to install it laying flat like this. I don't really need this drive, but I thought it would be a fun project. Okay, let's pull what's left of that crystal next. Not so easy. My desoldering gun is too thick to fit in between these resistors. I guess we could clear the through holes from this side. Yep. Well, we can't use this guy here because it has a big gaping hole on its side here. So that crystal is pretty useless. But I think I found a replacement on a scrapboard. But unfortunately, this is the wrong form factor. So we're gonna have to bodge something here. Let's remove this other crystal here first. Then see what can be done here. Okay, I think I have a solution here. Soldered thin piece of wire to one of the through holes. Then we can solder the crystal directly to the pad on this side and to the small piece of wire on this side. I think this might work. It's a bit dodgy, but this is what we've got, so this is what we'll use. I'll use some flux and a large blob of solder on this side. And now we can reflow the solder and add the crystal to the pad. Yep, I think that worked. This side could be a bit trickier because the wire is so short. It may get unsoldered in the through hole when we solder the pad on the crystal. But let's just try this and hope for the best. Yeah, my bodge wire definitely moved. But that doesn't matter as long as it's connected to the crystal. And it is. This whole crazy contraption here actually sits quite firmly. And the other crystal is quite useless too. It has a big bump on the side. And there's absolutely nothing left of the broken off pin. So I can't solder a wire to this crystal. So we'll try the same thing with this crystal here. I'll add a big blob of solder to this pad. Some flux. And here's what the SMD crystal looks underneath. So pretty large pads, but they're not very accessible from this side. This is a reused crystal too, from a scrap board. Okay, firmly attached on this side. Let's add some flux. And a blob of solder. Yeah, that crystal sits super firmly. I'm pushing quite hard on these, so I think this might work. I'll clean this mess up before we continue. Okay, so next up we have the ripped off pin here on this NEC chip. So I guess I'll try to bend the pin back to its position. So half of the pin is left on the board and half of the pin is coming out from the chip. And after bending them, they are now touching each other. So big blob of solder here should reconnect it to the PCB. Let's add some flux and a splash of solder. That should do the trick. And then we have a whole bunch of pins that are pretty badly bent. And some of them are shorted. So I'll just use a small screwdriver and bend them back into position. Okay, next up we have the horror show inside the connector here. So first I thought I would just replace it, but I did an inspection here and I don't see any pins missing. So I think I'm gonna try to straighten them up. And if it doesn't work, we'll replace the whole connector. But I think it could be worth a try to just straighten them up. No, that was no fun. That was too much work. So let's try this instead. I'm going to add some chip quick to this side of the connector. That way it will require much less heat and the solder will stay molten for much longer. Then I'll turn the board around and heat this side up with a rework station. And hopefully we can apply enough heat to melt the chip quick on the other side of the board at the same time as we melt the solder on this side. I have never removed one of these connectors before, so I'm kind of guessing here, but I'd say that was not a bad guess because it's coming off. Yep, that totally worked, and it only took a few seconds. Next we need to remove all the chip quick from this side of the board, so let's add some flux here and use some wick. So I'm going to do this a few times to make sure all the chip quick is gone. Okay, both sides cleaned up. The old solder and the chip quick is completely gone from the board. So the next problem is that I don't have a new connector. So we're gonna have to use regular pin headers instead. But here's the issue. If we zoom in, this might be a bit hard to see because of the old solder and the chip quake on the pins. But if you take a close look at these pins here, you can see that they are bent in to match the width of the PCB. So with regular pin headers there is at least 1 millimeter between the pins on one side and the PCB. But I guess we could bend them with pliers. I'll give that a try. Yeah, that was super easy. I just used some needle nose pliers and all the pins on one side are now bent in and all the pin headers are now sitting on the pads. So I'll just quickly solder all these pins to the pads. Okay, said and done. The homebrew connector is now soldered to the board. So I'll clean this mess up and then I'll check those scratches I noticed earlier. Okay, I checked all the scratched up traces, but I couldn't find any breaks, so we're all good to go. I'll reassemble the drive and we'll try it out. Okay, hard drive connected to the motherboard. Here goes. Oh no, it doesn't boot. That hard drive didn't spin up. Oh crap. Well, I did a couple of reboots. I think it was trying to spin up, but it didn't. So that kind of sucks. So let's do what we are told to never do and open up the lid. I think we also have a hidden screw underneath the warranty sticker here. Well, that's a funny looking screw. How about the sticker here? No, that was just a tiny hole. So, I need to figure this guy out here. Let's try to undo that locking nut. Now let's try to pull that lid off. Yep. Okay, looking pretty nice and clean in here. I'll gently twist the platters and see if they move. And they do, so the drive is not stuck. Oh crap. So this is not a mechanical fault. There is something wrong with the electronics on this drive. Bad enough to prevent the drive to even spin up. Okay, let's see how this drive behaves when we turn the power on. I move the head slightly away from track 0. Now let's turn the power on. Okay, and it moved the heads to track 0. But unfortunately it doesn't spin up. Well, I'm not sure about these crystals here. I found these two guys here in a very similar drive. The original crystal was marked 400 NDK 0X. And this guy here 320 NDK 08. Unfortunately I couldn't find any data sheets and I wasn't able to identify these two crystals on Google either. So then I had a look in another drive. This one was made in 1994 I think. And it has a similar set of crystals here. So this one is marked SF400. This guy here SF320. So it seems to me this is some kind of standard set of crystals for a hard drive. At least for SCSI drives from the early 90s. The crystals I used are marked 40,000 KSS4G and 32,000 RVR 430. So there is a risk that these are the wrong values, but it's not super likely. Unfortunately, I don't know enough about how this hard drive works to know if a wrong crystal could prevent it from spinning up. But I don't find it very likely, because as soon as you apply power to a hard drive, it will start spinning right away. But again, I'm definitely not sure here. So I'm gonna put this hard drive aside for now. Perhaps we'll play some more with it in a future video. I find projects like this kind of amusing, so I'm not ready to toss it out quite yet. Okay, so next up we have the partially working board from a previous video. The battery had not exploded on this board, so there is no damage in this area on this board either. But the caps had leaked quite severely, so there was a lot of corrosion on this board. And after the recap it partially works. So we're getting a white screen and a mouse cursor, but it doesn't try to boot. And the first obvious thing to do is to take care of these axial caps here. When we recapped this board, I didn't have these axial caps at hand, because I didn't think they were bad. But check this out, we have some green nasty stuff here So this could actually have been caused by these SMD caps leaking, and the cap juice may have found its way up the lead here, but it's more likely that it's coming out from this cap. So now that I have some caps at hand, let's replace these and see if it makes a difference. Since we know these are a bit stubborn, I'm going to add some leaded solder right away. I also cranked up the heat a little bit on the desoldering gun, because this board has a pretty thick ground plane. And the two caps have now been replaced, making this a fully recapped board. Okay, board hooked up to the display. Here goes. Okay, the display turned on, and we have the mouse cursor. Now let's see if it will try to boot. No, nothing. We're not getting a question mark. Although I have a disk in the drive, so it should actually boot by now. Okay, that was not our issue. At least not the only one. The next thing I noticed when checking the board was that I was a bit too quick when restoring it. So there's actually still some corrosion on this chip here. And this is actually the SCSI chip, so that would definitely explain our issue. And with solder joints this crusty, there could very well be a crack in the solder joint. So next I'm going to reflow this chip here and double check and make sure I didn't miss any other chips. I'll do it off camera, not to repeat myself. You know the drill. Flux heat and a big blob of solder. Okay, I'm done. And here's the result. While I was cleaning this chip, I got the nastiest stench. If you have ever restored a board with leaky caps, you know how bad old electrolyte smells when it gets hot. So this chip here had some trapped cap juice underneath. That could possibly have caused our issue. I've had this happen once. That Mac had some really weird behavior until I washed the board. Alright, time for a new test. Here goes. Screen lit up. We've got the mouse cursor. And unfortunately, not much more. It doesn't even try to boot. So we probably have a bad chip, or possibly a broken trace underneath one of the chips. Well, now that we have one working board, we also have a full set of working chips. So the next step, I guess, is to swap the SCSI chip. Or I guess we could bring out the schematics and start poking around and see if we can find a broken trace. Well, one fixed, 2 to go. But this is all I had for today, and I'll see you guys again next week.